So hello guys. In this tutorial, we are going to explain to you the infinite set. An infinite set is one in which it is not possible to list and count all the members of the set. So it means it is not countable. So now, I will give an example of an infinite set. Example number 1 is set A says even numbers that is greater than 13. So now we will write down the even numbers that is greater than 13 in set B. So these are 14, 16, 18, 20, 22, and so on, so forth. Example number 2. Set A says whole numbers that is greater than 1,500. So now we will write down the whole numbers that is greater than 1,500 in set B. So these are 1,501, 1,502, 1,503, 1,504, and 1,505, so on and so forth. So now, example number 3. Set A is equal to x such that x is a natural numbers. Since all the elements of set A has an infinite numbers, so we can say that set A is an infinite set. So now example number 4. Set f is equal to x such that x is a fraction. Since all the elements of set f is an infinite numbers, we can also say that set f is an infinite set. Next, example number 5. Set e is equal to x such that x is an even numbers. Since all of the elements of set E is an infinite numbers, we can say that set E is an infinite set.
Finite and infinite sets are two different types of sets. The word finite itself describes that it is countable, and the word infinite says it's not finite or uncountable. Here you will discover all about finite and infinite sets, like their definition, properties, and other details of these two types of sets, along with various examples and questions. Finite sets are the sets having a finite or countable number of members. Finite sets are also known as countable sets, as they can be counted. The process will run out of elements to list if the elements of this set have a finite number of members. Here are a few examples of finite sets. First, set P contains 0, 3, 6, 9, up to 99. Set Q contains A is an integer, and 1 is less than A, but A is less than 10. And lastly, a set of all English alphabets, because it's countable. And here's another example of a finite set. A set of months in a year. Set M contains January to December. So, N is equal to 12. It's a finite set because the number of elements is countable. Now let's talk about the cardinality of a finite set. If A represents a number of elements of set A, the cardinality of a finite set is n of A equals A. So the cardinality number of the above set is 26 because the number of elements in the alphabet is 26. Hence, n of A is 26. Similarly, for a set containing the months of the year, we'll have the cardinality of 12. So this way we can list all the elements of any finite set and list them in the curly braces or the roster form. So here are the properties of sets. The following finite set conditions are always finite. First, a subset of a finite set. Next, the union of two finite sets. And last, the power set of a finite set. So here are a few examples. Set P contains 1, 2, 3, and 4. Set Q contains 2, 4, 6, 8. And set R contains 2 and 3. Here, all the P, Q, and R are finite sets because the elements are finite and countable. R is a proper subset of P. Example: R is a subset of P because all of the elements of set R are present in P. So the subset of a finite set is always finite. Next, P union Q is 1, 2, 3, 4, 6, and 8. So the union of two sets is also finite. The number of elements of a power set of a set P is 2 raised to 4, which is equal to 16. As the number of elements of set P is 4, so it shows that the power set of a finite set is finite. Now let's talk about non-empty finite set. It is a set where either the number of elements are big, or only starting or ending is given. So, we denote it with the number of elements with n of a, and if n of a is a natural number, then it is a finite set. For example, set S is equal to a set of number of people living in India. It is difficult to calculate the number of people living in India, but it's somewhere a natural number. So, we call it a non-empty finite set. If n is a set of natural numbers less than n, so the cardinality of a set n is n. N is equal to 1, 2, 3 until so on and so forth. X is equal to x sub 1, x sub 2, and so on and so forth as well. And y is equal to x such that x sub 1 elements of n, x sub 1 less than or equal to I greater than or equal to n, where I is the integer between 1 and n. Can we say that an empty set is a finite set? Let's learn what is an empty set first. An empty set is a set which has no element in it and can be represented as braces with no value at all, and shows that it has no element. For example, P is equal to a set or certain set with no value. As a finite set has a countable number of elements and the empty set has zero elements, so it is a definite number of elements. So with a cardinality number of 0, an empty set is a finite set. How to know if a set is a finite or an infinite? As we know that if a set has a starting point and an ending point both, it is a finite set, but it is an infinite set if it has no end from any side or both sides. Here are points to know a set as finite or infinite are. Infinite set is endless from the start or end. Both the side could have continuity, unlike in finite set where both start and end elements are there. Next, if a set has unlimited number of elements, then it is a finite, or my bad, infinite, and if the elements are countable, then it is finite. Here's a graphical representation of a finite and infinite set. So, set A is equal to 1, 2, 3, 4, 5, and set B has 1, 2, 6, 7, and 8. Now, A union B is equal to 1, 2, 3, 4, 5, 6, 7, and 8. And A intersection or intersects B is equal to 1 and 2. Both A and B are finite sets as they have a limited number of elements. Hence, n of A is equal to 5 and n of B is equal to also 5. A intersection B and A union B are also finite. So, a Venn diagram can represent the finite set, but it's difficult to do the same for an infinite set, as the number of elements can't be counted and bounced in a circle. The union of two finite sets is finite. That's all, and thank you.